A linked list is traversed by visiting each node exactly once. The traversal usually starts from the beginning of the linked list and ends at the last node. However, you could traverse from any node in the linked list as long as you have reference to that node. To get to the beginning of the linked list, you would need to make the variable current refer to the same object which head refers to. And in this example, head refers to this node 28. So to make current point to this node 28, you would need to execute the statement current equals head. By this, current now points to or refers to the node 28. The data member next of current refers to the next node in the linked list, which is node which has a value 30. So to make current refer to this node, you would execute the statement current equals current dot next. By this, current now refers to the node 30. The data member next of current now refers to the node 7. So now to make current refer to this node 7, you would need to once again execute the statement current equals current dot next. By this, current now refers to the last node, which is 7. The data member next of current is null as depicted by this shaded area. So when you execute the statement current equals current dot next, current is null. So the terminating condition for traversing a linked list is when current is null. We are in the Eclipse IDE. Let us now implement the method traverse. This method traverse takes in no parameter. We first check whether head is null. If head is null, we return or we quit, indicating that the linked list is empty. On the contrary, if head is not null, then we set current equal to head. And we traverse the linked list while current is not equal to null. And as we are traversing, we set current equals current dot next. As you recall, the terminating condition is when current is null. When current is null, we have reached the end of the linked list. So this condition is false and we terminate. So with this, we have implemented the traverse method. Let us now implement another method which is quite similar. Let us implement a method which will compute the size of a single linked list. This method size also takes in no parameter. Let us first initialize a local variable size to 0 and let us initialize current to the node which head refers to. While current is not equal to null, let us increment the value of size by 1 and let us set current equal to current dot next, and finally let us return the value of size. So when the linked list is empty, head refers to null, so current is null, and this while loop condition is false. So as a result, when this statement return size is executed, the value that is initialized, which is 0, is returned. On the other hand, when the linked list is not empty, head refers to a node in the single linked list. In fact, it refers to the first node in the single linked list. So current is not null and the value of size is incremented by 1. Current is set to current dot next, and again current is checked for null. If current is not null, again size is incremented by 1 and line 27 is executed. Finally, when current is null, this condition is false and as a result it will exit the while loop and return the value of size.